So if we draw perpendicular lines on this electric field, then those perpendicular lines, just like in the last scenario, those perpendicular lines are going to represent a potential difference. Okay? And we can do that again. This is going to represent a potential difference. And of course, we can do it again. All right, so that took care of this entire piece. Let's see, that was purple. Okay, so we'd have a different potential there. All right, so let's just go ahead and label this. The first one, the first potential here is just going to be V1. Ooh, that's hard to see. V1, V2, and V3. So we can define something called potential difference. And this could be V3 minus V1. It could also be V2 minus V1. Okay, so we have potential difference. We also have what is known as an electric field here. Okay, so it represents the same kind of thing as a gravitational field. It should behave the same way. And we have what is known as electric potential energy. This is just going to be the charge, some test charge out here. All right, I'm gonna call it QT, Q sub T, moved in this potential. So if it moves from, it's just gonna be delta V. If it moves from V sub 2 to V sub 1, it's just gonna be V sub 2 minus V sub 1. I mean, actually V sub 1 minus V sub 2. So that would look something like this. All right, so this is our electric potential energy. So if you remember, over here, we had our gravitational potential energy, and we have our gravitational potential. Now let's look at the force, the electric force. So our electric force is going to look like this. And I'm just going to make it Q. It's equal to kappa times Q1 times Q2. You know what? In this case, let's call it Q times QT over R squared. So that's going to be the distance between those two charges. All right, so the center of this charge, and let's just say the center of this charge, this would be R. So now you can rewrite this as F sub Q equals to QT times E, which implies that E is just equal to kappa Q over R squared. So look at this. This looks like how we define gravity. If you go back, oh, wrong thing. If you go back, you'll see gravity. We have our universal gravitational constant, we have our mass of the Earth, and we have the distance of separation between the centers of the two objects that we are considering. So that's kind of cool. This is where we're going, okay? So we have potential, electric field, electric potential energy, and force. Okay, so let's see. I want you guys to know that potential difference is going to be measured in volts. So when you think about volts on a battery, you could think about this potential difference. All right, so those are the units that we are going to use.